It's a smoke machine, and despite the fact that, there's a huge backlog of things to take apart, this one skips straight to the front of the queue because it's completely amazing. Well, not so much this one, but its brother, and we'll see that shortly. So here's the remote control with its little flickery LED. I'm going to push the button. Smoke! Yeah, the room's going to be really smoky. Oh, I've just thought of something. Just give me a second. eBay's shittest smoke detector. Let's test it. Oh, is it doing anything? Oh, I think it's, oh there, oh my god. Let's evacuate the building. Yeah, you deaf yet? Yeah, it's the quietest smoke detector I've ever come across. Anyway, I digress, but I just can't resist pushing this button and creating even more smoke. This is a custom smoke fluid. I didn't have any smoke fluid in stock. This is just glycerine and water. It's actually got a drop of e-liquid in it, nicotine-free e-liquid, just for the aroma, which is a fusion. It's quite nice. It's a fruity, licoricey, mentholy smell. It's quite nice. Oh, yes. Smoke machines are fun. I often fog my place out, the smoke machine, just for no good reason at all. So I'm going to unplug this now, and let's take a look at the anatomy, because this is one of the cheapest machines you might find. Where's the cover? The cover looks like this, and it usually is something like 400-watt fogger printed inside or something thereabouts. And the operation is very, very simple. Making sure this is unplugged, we have a heater block here, which has an aluminium core. If I tilt this up, you'll see the aluminium core up the end in there. This is very, very hot. Oh, you know what? Temptation is to actually find out just how hot this is. How can I do that? I think a thermocouple might be the best thing for this. Just give me a second, I'm going to check that. Okay, bit of thermal inertia. It cuts out around about 270, and then there's a bit of thermal inertia taking up to about 300 degrees Celsius, which is pretty common, I would expect, for these machines. The science behind a smoke machine is quite interesting. I'll unplug this before starting pulling my probe back out here. The science behind smoke machines is very simple, actually. You have a solution that is based on water and glycol, and they fuse together. They form a one liquid. When you add the water to glycol and shake it up, it mixes in. And when you heat it in a pipe that is very, very hot, well above the boiling point of water, the water in the liquid boils, and because the glycol's temperature is much higher, it shatters the glycol apart into tiny little droplets which blow out the end as a fog. Let me have more fog. Fog. Ow, that's quite hot. And that then creates the sort of the haze in the air is actually tiny little droplets like lenses. It's very, very simple. The same system works with e-liquid, except it's a different heating system. Instead of actually relying on the boiling of water, well, it is still boiling water, but you're using the wick with the heating element in the e-liquid, and it's the natural moisture that's present in the glycol and glycerine, which is very, very hygroscopic, absorbs a lot of water that actually shatters it apart and creates that effect. So this is just running just the easiest smoke fluid I could make, which was glycerine and water. Generally speaking, smoke machines will use a glycol like triethylene glycol, propylene glycol. The one glycol they don't tend to use is, well, the glycols they don't use, the harmful ones like ethylene glycol antifreeze, is not suitable for smoke fluid. But I think one of the most common is triethylene glycol, but they often mix the glycols. I don't know if that creates a shattering effect of different lenses with different refractive indexes, because I think it creates a thicker fog. The smoke machine manufacturers are all into, they're all saying, only use our liquid, it's very special and it's formulated this way and that way. And you don't really know what to believe. It's all full of sales-motivated bluffing. But anyway, I digress. We have the heating element here, making sure this is unplugged, which is probably a U element. I know it's a U element, actually, because I've had a closer look at the insides of one. And you have the pipe that's going in from the little solenoid pump. You've got the bimetallic cutout here. It's the disc type bimetallic, and I thought this machine had no secondary cutout. It's quite common to see a thermal fuse in these as a last resort. I have a sneaky feeling there may be something like that built into these, owing to the fact that the next exhibit is another one of these that has overheated quite badly, and it has gone completely open circuit. So we'll open that as well and see what's inside. We have the heating element with the pipe wrap round it, I presume here, and then all encased in the aluminium. The aluminium is there as a heat reservoir. It's to give it higher, greater mass, so that, you plug this in, it takes a while to heat up, it's heating that block up, and then it will hold that heat for quite a time as you pump the liquid into it as well, and only when it gets cool enough does it kick in again, heat it up again. This white stuff is not asbestos, as some people will inevitably say. It is sort of ultra pure fiberglass, the sort of stuff you'd find in like kilns and stuff like that, to add thermal insulation. It just basically isolates that internal block and keeps it from overheating inside the machine, and also reserves the heat. It just stores that heat inside, so it's not just a heater. This is a solenoid pump, and it's got a little reciprocating piston inside, and the piston goes into a cylinder like that. Yes, I know that's going to get weird, smutty sex comments. And there are two-way valves, and in line with that is a diode. There's the diode there. Can you see the diode here? It's just actually soldered in line in the wire and covered in heat shrink sleeving. And that means that although this is a mains powered solenoid, when you power it up, it only fires in half cycle. So it doesn't matter the polarity. When it fires in that half cycle, there's a slug of metal inside that pulls back, and that's a little connected to a piston. And it pulls back, and then on the other half cycle, when it's not powered, it then returns under spring pressure and pushes a portion of the liquid through. And it's the cheapest pump they can use. It just doses through at a very accurate speed, and that's what they want. So we have the incoming supply here. We've got live and neutral coming in. Earth has just been cut off for some reason. It's not unusual for Chinese products to have the earth cut off. It's odd they've used 3-core flex and it's cut off, and there is a little post for it here to be earth. I don't know what the situation is with that. And then we have the connection going out to the remote control. And unfortunately in this instance, the connection is ready for the sound guys to get very upset. It's 3-pin XLR with 240 volts on it. Excellent. That's also used for some DMX. The cheap DMX equipment has the 3 pins. Let me think. What would that be? I'm just going to look. I've got the schematic here. I'll show you it later. Schematic here. Just give me a second. Pin 1 would be screen in DMX, which would be neutral, which is close enough. Pins 2 and 3. Oh, Jesus. Right. Pins 2 and 3, if you plugged a DMX line into this and then connected to a string of lights, and you powered this up, as soon as this thermal switch went open circuit, as soon as it's up to temperature, it would basically just pump 240 down your DMX network and kill all your lights. Excellent. In the remote control, which has 2 LEDs, it's got one LED to show when it's ready to actually pump, and it's got a green LED to show when you're pressing the button, which is a bit pointless. Let's open this up. So I'll just whip these out. The machine I'm going to show you shortly is just so exciting because the way it's failed, it's just fantastic. In this very simple, no circuit board or anything, we've got the push button, 2 1K resistors, brown, black, yellow, that's 1 0 and 4 zeros, so that's 100,000 ohms. And they're going to LEDs, which the LEDs are then connected to this red wire, which in the schematic was actually neutral. Okay, and when you push the button, it bridges the yellow and black in this case, and it runs the pump. So let's get this out of the way. I'm just going to clear this off and get the drawing in, and then we can take a look at it. Oh, it is so foggy in here. So let's take a look at the different modules here that make this up. Is this focus? Is it in focus? It is now. If I cover this and we look at the main heating circuit, we've got the live feed coming in. It's going through the power switch. It's going through the heater. And then there's the thermostat, the thermal switch to neutral. So what's going to happen initially when you turn this on is the heater is going to heat up. Once it reaches the correct temperature, that will click open and break the circuit. Next module we'll look at, just to get it out of the way, is the power switch has a neon indicator in it. It's got, the neon indicator is connected from the output to the neutral connection, which just purely, that's the whole function of that neutral connection on that switch, is purely to make the neon indicator light. It's got a resistor inside, neon, and when you turn it on, it lights up. I'm quite surprised they actually used an illuminated neon switch in this, given that everything else seems to be a bit cheap. After that, we have the 3 connections going out on the XLR. Pin 1, pin 2, and pin 3. Pin 1 is connected to neutral. Pin 2 is connected to the pump, and pin 3 is connected to that side of the heater. The side of the heater before the thermal switch. And the idea of this is that you can't really run a smoke machine when it's cold, because if you run the pump when it's cold, the liquid will just get pumped through and it will squirt out the end. It will make a real mess. So what they do is this. They put the pump effectively across the thermal switch. And that means the pump can only run in series the heater. And keep in mind the heater is very low resistance, so it's nothing compared to the pump. It was almost like a dead short circuit to the pump. When they bridge between here, the pump will run, but only when it's up to temperature and that thermal switch is open. After that, there's a switch down there. In fact, I could have just pointed out the switches down there. After that, we've got the 2 little indicators, one which is normally bridged out by this thermal switch here, so that none of the indicators will light as long as it's heating up. And then one that will only light when the thermal switch is open, the red lights, and then you push the button, the green lights, which is a moot point. It just shows you're pushing the button. Previous systems were a bit more sophisticated. They had a red LED that showed power was on and a green LED that showed when it was lit. Interestingly, in this one, the neutral became detached off the back of the connector. Is that right? Yes, it was. It was still connected to the pump, but it came detached from the connector, so it was broken here. And it still found current through the LED to actually light the red LED when it was ready to run. It's worth mentioning this is not a great way to run the LEDs, because they're using the old school gallium arsenide red and gallium phosphide green. And they put 100k resistors in series with them, and that means that you'd think because it's a diode, it's only going to conduct in 1/2, but in reality, they're actually making these diodes, LEDs, conduct in reverse as well. So that resistor there is actually dissipating a lot of power. That's dissipating over 1/2 watt for a 1/4 watt resistor. Not so bad for the green one because it's just operated in brief cycles, but normally in standby, once that's up to temperature, this red one's lit all the time. So not great. I would have used a higher value resistor or simply put a series diode in, but they didn't. Yeah, they could have actually. No, they couldn't have. I'm just talking shit. Just ignore me. They'd have to put a diode in each one. I was going to say they could have put a diode, just one diode there, but in reality, then it would still find a current path through the other LED by reverse biasing it. Anyway, ramble. I'm just completely off at a tangent there. But that's the principle. It's very simple. It means that you plug it in, it heats up, thermal switch opens, and that means you can then run the pump when you push the button. That is how the smoke machine works. Let's go and get the next exhibit. So I'm just going to pause while I go and grab that. I'll be back in a moment. Okay, next exhibit starts rather ominously with a skid mark in the top, melted wires on the case where they've been lying over the surface of it. I'm not sure if that was part of the factor here or not. And when you go inside, the unit has just basically a huge pool of aluminium at the bottom, which used to be the heater block. And that's what this thermal fuse used to be screwed onto. Because something has gone horribly wrong. And this unit has just kept heating until literally the entire aluminium block in here, like a little furnace in there, has just melted away. I'm kind of intrigued to see, can I get this cover off? Is it jammed on solid? No, it's unscrewing. That's quite good. Everything's been overheated. The back of the XLR connector has been overheated. And there's a couple of possibilities for this. This screw, no, it's coming out. This is going to give us an indication of how these things actually work. I particularly like this nice molten blob of aluminium that has dripped out. Someone suggested the temperature might have gone up to 600 degrees Celsius in this for melting the aluminium. If that is aluminium, it will be an alloy of some sort, which obviously aluminium is. But is that what this is? What's intriguing is that the thermal cutout here If I bring in the meter, let's bring in the meter and put it to continuity. There is no continuity across that, as if there's some last resort cutout in this. So a couple of possibilities here. Either that thermal switch has failed, which it is now open circuit. Is this going to come off? There it goes. I do hope it isn't asbestos. I don't think it is. Here is the heater, which you rarely ever see in the flesh because they don't normally melt all their guts out. Right, that is very interesting indeed. That is very interesting. Right, I shall doodle that down for you later, if you've not already worked out what it is from this. So let's take a look at this. The other option is that, technically speaking, let's get this open. The other possibility is that something has happened externally because of the way that's designed on the schematic. It means that if something goes wrong here, and you have a means through the XLR connector to bypass the thermal switch, if you were to bridge pins 3 and 1, you would effectively be bypassing that. But also if pin 3, the wire associated went to ground and there was no RCD or GFI, then it could effectively provide a current path from live through the heater to ground and keep that heater energized. I don't know what's happened here, but I like it. This is the most destructive failure I've ever seen in a smoke machine. It's fantastic. I'm looking for my snips here. I'm not seeing my snips. There they are. Let's peel this open. So I'm going to just move this to the side, and so you can share the moment here. Let's focus down. Let's find something around about the right height here. There's a lamp box. Let's focus down like that. How's that looking? Yeah, it's good enough. Let's get this open. So let's cut that little ring off for a start. Misuse my snips badly. And then, I like the way the screw is still got the alloy, because this was originally screwed into an alloy block. And let's peel this off. Is this going to come off easily? I'm partly looking at the camera screen here. So there's a little pin. There's the bimetallic disc underneath there. Under a little ceramic heatproof thing, which I'm about to damage. This is, I don't think I've ever taken one of these apart before. How remiss of me. There's a little bimetallic clicker that when it heats up should suddenly click inside out and then return to its original shape. There's a wee ceramic pin that pushes the contact in there. Is there anything that would have stopped that? Is that... Hold on. What's to stop this? Normally that would be closing down, it would be pushed away with that, but it has kind of retracted. Is that deliberately, or is it just because it's been nuked to the point of failure? I may have to go in further. This is where I have to actually nibble into ceramic, which is a terrible idea with expensive schnips, but I don't see any option at the moment. Oh no. What? I don't see any obvious device to make that retract. Is there a spring that pushes against that? Let's lift this out of the way. So what's this is supposed to be spring loaded and it's supposed to push up against that. But it's kind of almost like it's retracted. Is that deliberately that's retracted, or is it just because? I mean, is there some... there's no obvious mechanism here to make that retract and break the circuit, but it's done it. I would have thought there might have been a small spring pushing that up, but I don't see it. Because normally that would be spring up against this contact. And when the bimetallic strip kicks in, it should kick it down like that to actually break the contact. But I don't see anything obvious to actually make that do it permanently, unless this disc has malformed. Maybe it's just reached the temperature that's actually damaged the switch completely. That's odd. I was expecting something more exciting than that. I'm almost slightly disappointed, but that's okay. That's okay. So let's brush all those bits out of the way. And let's bring the notepad back in again and doodle other stuff. So let's zoom out a bit. Let's control this intensity because that is quite ferocious. Intensity and zoom down there. Right, okay. So here is the possibilities here. It's possible that something's happened external to this unit. If it's not the thermal switch itself that's failed, and that is possible, you know, it could have welded shut, but keep in mind this is only a 400 watt unit, so it's not going to be that much current. Strange. The other option is that the heater has found another path to neutral that bypasses that switch completely. But the interesting now that we know from opening this up, from looking at what looks like a bit of a skeleton here, well it is, it's a corpse of a smoke machine. What's inside in the heating block is they've got a heating element like this. It's this sort of standard sleeved ceramic-y heating element, with the ceramic sleeve coming out here and the metal sheath around the outside. The metal sheath actually looks all right here. And then the little tabs that come out the top, back, and then they spot weld the terminals onto it. So that it's a standard heating element. And they've taken the heating element, the pipe has come in. It's initially come in from about down, the pump's down here, so they've had no choice but to actually bring the pipe from this end. They couldn't really tuck it down like that. So what they've done is they've got the aluminium, they've tucked it in like that, down, and then it's gone. Let's see, how is this? I think they've got a channel in the, I think this may have been formed afterwards, the pipe, to actually go into this. But the pipe itself is just wound round that heating element. And it gets to the end, and it looks like they've actually tucked it through underneath and then brought it out the end. And that just creates a very large surface area so the liquid gets pumped in and it has to go through that pipe. And as it's doing so, it's getting hotter and hotter, and it makes sure it's all completely atomized. And I have to say, this little smoke unit machine is not bad. Many of the ones that have a cheaper path, some of them basically just had a void inside and a pipe going into it with a little flange and the nozzle at the end, and they might have had a couple of rings like that inside to try and create a complex path, but they often put through unexpanded liquid, because as soon as the liquid went in and it expanded the heat and started evaporating into steam, it would blow the other liquid through so quickly that you'd get droplets would come out the end and splatter, and it would make a real mess when you actually used it, particularly if you used a liquid that was not quite the optimal mix. But this is very good. It's not really splattered at all, and that's because it's got a proper traditional long path for that. But they've wound that pipe round it very tightly. You can see it's really just end to end here. It's side to side. It's like a wound transformer. And then they physically potted the whole lot in an ingot of aluminium, which then acts as the thermal mass, which keeps it, stores that heat, and allows you to run the fog for quite a lot of time before it actually needs to reheat again. So that's kind of fascinating in its own right, that the failure mode of this has allowed us to see the other insight into this. That aluminium in the bottom is just spectacular. That is just such a neat thing. It really is completely fused into the base as well. That could be so horrible if that machine was mounted overhead somewhere. But there we go. That is other thing worthy of note. This is a little one of those, is it sintered brass they call it? It's like a tiny little granules of brass that have been heated to fuse them together. What they're using that for is two reasons. It weighs it down into the smoke fluid container, And it also acts as a filter, so no dirt gets pulled in and can block the pump, because the pump has quite small holes in it for the sort of valve operation. So this acts as a filter and a weight to keep it down in the tank. So that is fascinating. That is a really interesting thing. I'm going to have to try and find out more from the person who sent these. Oh, there is another thing. There is just such a great thing. See the fuse holder? No wires onto it. The fuse holder appears to be for decoration. It has no fuse in it, and there's no sign of any solder in those wires, so it's never had the wire on it. It's purely to fill that hole, make it look as though it's got a fuse. Spectacular. Classy stuff. So, morals to take from this story. When you buy a cheap smoke machine from China, when you bypass the standard, the sort of import channels in your country that it's coming through companies where they have to actually provide, say, for example, in the UK it would have been Maplin sold a lot of these things. Rest in peace, Maplin. But they had to comply with European regulations. They would not have sold this. If they had, they'd have had to recall it. CPC, I think, do smoke machines as well. But when you buy it from China, it bypasses all that, and it looks like a bargain, but what you're getting is something that is potentially going to have no safety, it's going to have no earth, it's going to have no fuse, and it's going to be using an XLR connector that people could accidentally plug other equipment in. The first ones of these that were sold in the UK via approved channels came with IEC Euro-type connectors on them, which was also a disaster, because if someone plugged an appliance into the back of the smoke machine thinking it was an outlet, just a looped outlet, it could potentially have made metalwork in that appliance live, particularly the earth was not earth. So, yeah, it's impressive. I think this is stunning. This is definitely the best failure of a smoke machine I've ever seen, the complete melting of its thermal block. It's fantastic. So very neat. I quite like that. I really enjoyed taking that to bits and doing a little autopsy.